Friends, let's look at this circuit called low pass filter. Okay, generally we're looking at low pass filters and frequency response. Now, why is this called a low pass filter? Actually, a low pass filter passes low frequency signals, or it passes low frequencies and blocks high frequencies. It allows the passage of low frequencies and this allows the passage of high frequencies. How does this happen? Okay, let's have our voltage source Vs. Now, if current is, of course, this voltage produces current I. Okay, now when this current gets here, this is IR. Now, notice that R and C and this capacitor are in series. What I mean is, it's just like this. They are this way. They're in series and the same current flows through them. This is where it is. So one is just trying to measure the voltage across this capacitor. That's the reason this VC. This VC is also the output voltage. So they are in series. So the same amount of current passes through them. So the current through IC is the same. So by basic electronics, since they're in series, they have equal current passing through them. Okay. Now current is defined as I is V of R for this resistor. For the capacitor, with IC is VC over, in terms of capacitive reactance, we know that IC is the Q dt. We know. Okay, but this is also true in terms of capacitive reactance. Now, see what is happening between current flows from area of high voltage to area of low voltage. So the voltage, this voltage here will drop across the resistor. Part of it drop across the resistor. The remaining will drop across this capacitor. And so the voltage drop across the resistor will be the voltage source minus the voltage here. We call it potential difference. The voltage here is VC, see that? Divided by R. That is this current, okay? Now this other current will be the voltage across this capacitor, which is VC, which is equal to the output voltage, minus 0, because the voltage here is 0, divided by the capacitive reactance of the capacitor. Okay, so we have Vs minus Vc over R equals Vc over Xc. That gives us, if you cross multiply, you have Xc into Vs minus Vc equals RVc. See that? So if you open the bracket, you have Xc Vs minus Xc Vc equals RVc. So correct like terms, we have Xc Vs equals Xc Vc plus RVc. See that? Bringing out C Vc gives us, that's the output voltage, plus R equals VSXC. So output voltage, which is something as VC, will be equal to VSXC all over XC plus R. Okay, now basic physics teaches that capacitive reactance is 1 over 2 pi FC. Okay, 2 pi S. So notice what this. Now, if you take the limit, if F frequency, because F is frequency, what I mean is XC is, I write it here, over 2 pi FC. So it means that literally the capacitive reactance varies inversely as frequency. So if F is too large, if it tends to infinity, XC will be equal to 0. So if that happens, VC will be equal to 0. So no output voltage. Nothing happens. The output voltage is 0. Meaning, if the frequency, if a high frequency signal enters the circuit, it is disallowed. It is blocked off, and so you don't get anything as the output. But if frequency is very small, XC, will be large, tends to infinity. Now we take the limit when you see VC can be written as, if you multiply this x all over xc plus r, if you multiply by 1 over xc, do the same thing by 1 over xc, you will see that what you will have is Vx all over 1 plus r over xc. So we can take so we'll have Vc equals Vs over 1 plus r over xc. So if f is very small, x is very large. If it tends to infinity, r over infinity is 0. So this whole thing reduces to Vc equals Vs. So Vc equals Vs means that there is an output voltage for low signals. So this is actually a low pass filter. It allows the passage of small low frequencies and blocks high frequencies. Thank you very much.